Senior High School General Mathematics Core Subject. Evaluating Functions. Learning Goals. At the end of the lesson, the student is able to evaluate functions and solve problems involving functions. Evaluating a function. Evaluating a function means replacing the variable in the function, in this case x, with a value from the function's domain and computing for the result. To denote that we are evaluating f at x for some x in the domain of f, we write f of x. If we think of functions as a function machine, evaluating a function is analogous to providing our machines with a valid input. Example 1. Evaluate the following functions at x equals 1.5. Letter A. F of x equals 2x plus 1. Letter B. Q of x equals x squared minus 2x plus 2. Letter C. G of x equals square root of x plus 1. Letter D. R of x equals 2x plus 1 all over x minus 1. Letter E. F of x equals the floor function of x plus 1. Solution. Substituting 1.5 for x in the given functions, we have letter A, f of x equals 2x plus 1. Substituting 1.5 for x, we have 2 times 1.5 plus 1. 2 times 1.5 gives us 3. 3 plus 1 gives us 4. Next is letter B, q of x equals x squared minus 2x plus 2. Substitute 1.5 for x. We then have 1.5 squared minus 2 times 1.5 plus 2. 1.5 squared gives us 2.25, whereas 2 times 1.5 gives us 3. 2.25 minus 3 plus 2 gives us 1.25. Next is letter C, g of x equals square root of x plus 1. Substitute 1.5 for x. We have square root of 1.5 plus 1. 1.5 plus 1 is 2.5, square root of 2.5. Next is letter D, r of x equals 2x plus 1 all over x minus 1. Substitute 1.5 for x. 2 times 1.5 plus 1 all over 1.5 minus 1. The numerator now becomes 3 plus 1. The denominator becomes 0.5. 3 plus 1 is 4, divided by 0.5 gives us 8. Finally, letter E, f of x is equal to the floor function of x plus 1. Recall that the floor function of x generates an output for every input x equal to the greatest integer that is either equal or less than the value of x. So, for this example, substituting 1.5 for x, the floor function for the given number 1.5 would be the greatest integer equal or less than 1.5, and that is 1. So the floor function of 1.5 gives us 1. 1 plus 1 gives us 2. Example 2. Find g of negative 4 and r of 1, where g and r are as defined in the previous example. G of x equals square root of x plus 1. R of x equals 2x plus 1 all over x minus 1. For this particular example, there are no possible solutions for evaluating the functions g and r for the given values. Let's try to see why this is. Let's start with g of x. G of x equals square root of x plus 1. We substitute negative 4 for x. We have g of negative 4 equals square root of negative 4 plus 1. Negative 4 plus 1 gives us negative 3. Square root of negative 3. And as we know, we cannot extract the roots of any negative number. For the extraction of the root of any negative number, this would result into what we call imaginary numbers. But imaginary numbers is beyond the scope of discussion in general mathematics. As for the second example, we have r of x equals 2x plus 1 all over x minus 1. We substitute 1 for x. We have 2 times 1 plus 1 all over 1 minus 1. Now we have 2 plus 1 all over 0. And as we know, the basic rules for division, we are not allowed to divide by 0. This is what we call an undefined quantity. Example 3. Evaluate the following functions, where f and q are defined as f of x equals 2x plus 1 and q of x equals x squared minus 2x plus 2. Letter A, f of 3x minus 1. Letter B, q of 2x plus 3. Let's start with letter A. To evaluate f of 3x minus 1, we replace all of x in the given function f of x by 3x minus 1. Let's try to write first the original function, f of x equals 2x plus 1. From here, we replace all of x by the expression 3x minus 1. Resulting on this expression, and on the right-hand side of this equality, we have 2 times 3x minus 1 plus 1. To simplify, we need to distribute 2 to the expression 3x minus 1, resulting into 2 times 3x, which gives us 6x, and 2 times negative 1, which gives us negative 2. Simplifying further, we have negative 2 plus 1, that gives us negative 1, and our final answer would be 6x minus 1. For letter B, to evaluate q of 2x plus 3, again, we replace all of x in the function q of x by the expression 2x plus 3. Let's try to write down first the original function q of x. Q of x equals x squared minus 2x plus 2. We replace all x by the expression 2x plus 3. Resulting on this expression, which on the right hand side, we have 2x plus 3 squared minus 2 times 2x plus 3 plus 2. Notice that in this expression, we have 2x plus 3 squared, which is a square of a binomial. We perform the square of the binomial for this expression. As for the middle term, we have negative 2 times 2x plus 3, so we just simply distribute negative 2 to the terms 2x and 3. Okay, for the square of binomial, we square first 2x, that should give us 4x squared. We square 3, that should give us 9. As for the middle term, that would be 2 times 2x times 3. 2 times 2x, that gives us 4x. 4x times 3 gives us 12x. As for the middle term, we have negative 2 times 2x plus 3. Negative 2 times 2x is negative 4x. Negative 2 times 3, that would give us negative 6. Writing down all the solution for this expression, we have 4x squared plus 12x plus 9 for the square of binomial, and negative 4x minus 6 for the distribution of negative 2 to the expression 2x plus 3, then plus 2. From here, we combine like terms. Notice that we can combine 12x and negative 4x. 12x minus 4x is 8x. Whereas we can also combine 9 minus 6 plus 2. 9 minus 6 is 3. 3 plus 2 is 5.